So, I got some feedback on the mower that I built. And I'm not going to lie, this thing was a pain in the butt to build. Printer issues, waiting for parts, then just me editing all the footage that I recorded of it. But the feedback that I got was, if there's a list of some things that I like and some things that I don't like, some things that I'm going to change, some things that I would have changed, and I've kind of compiled a little bit of that. Starting with a couple of things that I like. One, it's a robot mower. Now, somebody else's design, but I started with a bunch of spools of plastic, and here we are. So, one of the other things that I really like is the bump sensors. Now, I'm going to switch over to the overhead camera and show you what I mean. Alright, so here we are overhead. So, one of the things that you might notice on here is, like right now, these are the inductive sensors for when I get the boundary wire put in. Right now, these are just empty. But there's no bump sensors. There's no little triggers. What it does is it actually monitors the current off of the individual motors coming off of here. So the code actually watches to see how much current is actually going to each wheel. And there was a calibration process where you kind of grab a hold of the wheel and add some resistance to it, and you can see that one side or the other would actually start to go up. So it's indicating that there's more current going to that because there's more resistance. So it can actually tell, just on the current going to the motors, which side is actually having an issue. So if it's going and I hit this front left side, it'll know that this wheel is the one that's having the issue. So a couple of things that I would change. One, if you look down in here, this MOSFET and this diode and whatnot, this is part of the power supply for the motor here. And during some of the testing, I actually ran into some issues with it not cutting very well. So as I adjusted the settings higher to give it a little more power, I think it ended up burning out. So either I've burned out this MOSFET, burned up a wire on the bottom side here. So I've actually got to take this out and make some changes to it. Now, one of the things that I would like to do is put in something very similar to this. This is our motor driver that runs our wheels right now. The drivetrain for this is set up for about 3 amps output using this motor, so it can do a little bit of juice, but it's not a lot. This one, however, is specifically designed for much higher current usage, which is where hopefully something like this guy will come in. So this is an H-bridge motor controller just like this one, but as you can tell, the power supply, or the heatsink for this, is significantly larger than this one. And this one's a dual H-bridge, and we've got the dual H-bridge on this one too. But this one can actually handle 43 amps, way more than we should ever put to this motor. So there are some R-sense and L-sense pins on here. So with these, hopefully we can actually do the same type of thing that we're doing here, and I can actually detect the current usage going to the cutting disc. Now, one of the things that I would like to do with that is modify the code with this, detect how much current is going to the disc. If the cutting disc starts to struggle, then using that feedback, we can then tell the rest of the drivetrain, slow down a little bit. We might be getting into some heavy grass, we might be getting into some wet grass, that type of thing. So we might actually be able to get this to be a little smarter about the way that it works. Another thing that I would change, and I actually did have to change this, was the cutting height. So you can see, kind of, that the cutting height isn't too bad. However, here in Florida, the grass in my yard tends to be thick and kind of wispy. And I think what happened while I was doing my testing is, since the grass is pretty thick, the actual height was pretty tall. But these wheels, I think, because of how narrow they are, they actually fit in between the blades of grass pretty good. So the first time I did this, when I had this little riser set to its initial size, at its tallest setting, I was almost scorching the grass, because when I first did this, this was really, really low, and that was using the default print. So what I ended up having to do is the axle that goes from here up to here, I actually had to replace, and I redid this whole piece. I printed new ones of these, put a new idler wheel on it, and then put a really long axle so that I could get this height. And you can see I'm already still at its highest point, and it's still a little bit too low for my comfort, because during the summer it's going to scorch pretty bad if I cut the grass too short. So I had to replace that. So I think that if the wheels were a little thicker, or maybe increase the size of these wheels, I think that would work. Along kind of those same lines, this is the front of the mower. And one of the things that I really kind of was surprised at is, while this is going, your tall grass is here. So we're using the wheels and we're pushing this small little idler wheel, which, you know, does pretty good. I mean, it's nice and, you know, it's nice and smooth. It's got a nice bearing and stuff. But we're pushing this small wheel through tall grass, or taller grass. This might not be as much of an issue after the mower has been running for a long time and it's kept the grass pretty good. But the experience that I had with it is, you've got some tall grass that's putting some resistance here. And then as it's going in, the cutter disc is now having to go into that taller grass too. One of the things that I ran into without having the covering on this is that there's not enough weight here that I actually had this thing pop a wheelie multiple times, because the torque on the actual drivetrain was enough that it literally just pulled the whole thing up. And now, you know, then there was no more resistance here, so the whole thing just kind of went, and then it would drop down. Now, during some of my testing, when I was working on this, I actually just took the previous axle, stacked some washers and a couple of nuts in here, and didn't have this top piece on. And unfortunately, I didn't record it, but it actually did kind of bite me, because the whole thing lifted up, left all of this down on the ground, moved forward, and then dropped. When that happened, it caused the disc that I had to completely shatter. I broke blades. It tore out of the actual disc itself. It was bad. It was not a good test. But it kind of indicated that maybe some more weight could be placed in the front here. And that's actually what some of this dust is I actually put some rocks out of my flower bed in the front of this to help keep this down during my testing. Now, the original design for this called for one type of motor or another, and you could put it wherever you wanted. I ended up building some batteries out of 18650s that I had, and ended up putting, each one has its own little 3S charging circuit. So you can see it on both sides. Then I made an adapter cable for when we're actually running the mower, so that I could actually have both of them are now in parallel, and we would actually get the extra juice of both batteries to allow for longer. So I haven't put the new charging stuff on yet. I do have the charging adapters for the individual batteries, so the whole thing, set it on the desk and just hook up the chargers to it so that I can recharge those batteries. Direction for this thing goes, like I said, this is the front side, so you do get some resistance there. I think if I were to do this again, or another design, I kind of like the concept of maybe these being, you know, the back wheel, or these wheels, you know, the actual drivetrain being more on the front, so that the mower would actually drive more like this. That way, the blade is, you know, being, you know, there's almost no resistance here in the front as it's coming in, And then the idler wheel is basically being pulled through short grass to create a lower resistance to it and a little less friction. So I think that if I was going to do it again or do another design, I think something like that I think would actually work a little better, because the distance to cutting the blades is about the same on each direction. Speaking of our cutting disc, one of the things that I found out, unfortunately the hard way with this, is I definitely do not like this style of cutting disc. And like I said, when I had this fall and this actually dropped, and you can actually see there was actually some damage, part of the bolts and stuff, when they shattered, it literally blew a hole into this casing. So if you look here, there's actually a screw hole right here. And what that's for is you're actually supposed to put another nut and a bolt right here on both of these blades. So the disc is actually coming around like this. So it's supposed to be so that with that second bolt there, that if it, that the blade kind of rests against it. Now, the downside to that is, like when it hit my test bolt axle, something had to give. So you've got a metal bolt here, a metal bolt here, a blade that's actually designed to break away here, because these are just utility blades. Same thing on this side. So when it came down and it hit that metal bolt, the softest parts to this were these blades to shatter, which means leaving little pieces of razor blade in your yard, and plastic. So right now you can see I have these bolts removed, and I don't even have the blades tightened down very tight. You can see they have some room to actually move. And if you look at any of the commercial ones, like the Husqvarna, the new Roomba, stuff like that, they're actually designed the same type of way. And I'm actually modifying this disc to actually hold those same blades that the commercial ones use, because Amazon has a pack of, it was like 10 or 20 replacement blades for $10. And because the blades are at the way they're made, it's actually a cutting edge on both sides. So when your blade starts to go dull, you literally just unscrew the bolt, flip it over, and screw it back on. So you basically get two uses out of the same blade. And it's cheap. It's like 10 or 20 replacement blades for like $12. So with that, it's actually going to allow me to use a commercial blade that's already out there instead of these. Using these little utility blades, it's like 6 of these blades for $6. The cost is a little higher, and I've already had to replace these a couple of times because it hit something during my testing and it hit the axle. I hit a rock and it snapped them. So now I've got little pieces of razor blade that I had to use a magnet to basically pull out of my yard. So I like the concept of the other ones, and they're designed the same way that I've kind of got these, where it's just a single pivot, nothing here, and it uses the centrifugal force to keep them out. And then if it does hit something, if it, you have the dog's tennis ball in the yard and it hits it, it's, yes, it'll probably cut it, but the blade can actually give a little bit, and then centrifugal force will bring it back out. Because it's grass, the centrifugal force is going to be enough to keep the blades out. So with that being said, this design was not a terrible design. It actually taught me a lot about this, and I think there are actually a couple things that I would like to change, some things that I think will actually be useful, and I'm actually going to go ahead and put them back to the community, for anybody else that might be interested. I do have a couple of other designs that I've been looking at. There's a very interesting project that I found called the Liam. It's actually on, I believe, the 7th or 8th revision of the Liam, where all of this that's 3D printed, you don't have to print. It's just totes, like Tupperware. You print the wheels and everything, and then you can use whatever small container you want. So I'll probably continue to do a little bit more work with this. I do want to get the inductive sensors in. I'm a little hesitant on getting the sensors for the bump sensor for this working, because I've started to look into doing a sensor that is compatible with invisible dog fence, because I have a dog and she keeps running away, and because she keeps wanting to leave the yard, we want to put in an invisible dog fence in case she does get out the front yard. I've read that some of these inductive sensors, the little boundary fence, can actually counteract with those invisible dog fences, meaning that not only is your dog going to run off, so is your mower. So I'm looking to see if I can find one that will actually work for both. So I will do a little bit more work with this. Obviously I have this one working, so I am going to go ahead and continue to use it until I start my next version. The batteries are actually about to be rebuilt. These cells were actually built with just some spare cells that I had. I've got about 2,000 decent cells to actually make new packs with, and I've got my new spot welder that will actually help make these a little cleaner, and I've got these little BMS modules that I'm going to try to get inside the housing so that they're all nice and neat and buttoned up, and I'll put the end caps on it. Then the cover will go on it, which I have the cover already, and the inductive sensors will be kind of the last piece. There's another piece to this that I would like to do, and it's using an accelerometer. What that'll do is that's actually going to create a safety feature that in the event that the mower does tilt up, or somebody comes up and actually tries to pick it up, that accelerometer will basically cut the power to the drivetrain and to the cutting disc to get those blades to stop. And I may even go ahead and hook this up, since I'll bypass this and actually go to an H-bridge. I may even use it to be able to cause it to break, meaning, not to physically break it, but to slow it down and just add a little bit of current to reverse it, to slow those spinning blades down quicker in the event that the accelerometer detects that it's been picked up. We're looking at the different ones. The functionality is actually, they all pretty much use a set of sensors. You've got your battery monitor, you've got your motor monitors, things like that. I've actually started to design an actual PCB that will allow a couple of things like the motor driver, the Arduino, to actually just be plugged directly into said board, and then all of the other wiring, your LED ports, all that kind of stuff, will actually have nice little hookups, and it'll be a proper PCB. Once I get that finished, I'm actually going to go ahead and release it as an open source robot mower board. And any of the pins that aren't being used for this will actually be exposed, so that if people want to continue to do additional work, they can, because those pins will be available. And the Arduino will basically be put on. You'll just flip it upside down and mount it directly onto the headers onto the board. There's a lot of things that can be done here, and I think this one was pretty ambitious as a first attempt to this. If I had found something like the Liam initially, I probably would have done that, just because it was significantly simpler, because you start with a box, just a tote, and then you add to that. So all of this extra work didn't have to be done with something like the Liam project. Now, does the Liam look as clean as this? No. It looks like a tote wandering around your yard. But using that concept, it allows you to be able to change the form factor and change things very quickly. There's a couple of other projects that I found that are even more elaborate than this. They're still printed, and they're very clean and polished. They actually look like the Husqvarnas. They have security features like PIN codes to enable them, so that they have theft protection, so that you can't even walk away with things. As soon as you pick it up, it turns everything off and it disables it until you put in the pin. So there's a lot of really cool stuff out there. And based on what it took, if I hadn't had to spend the time to edit the video on this, and I'm not gonna lie, that's where a lot of my delays came from, is I shot a lot of footage. My last video for this was about 30 hours of footage that I compressed down into those 15 minutes. So editing that was a big part of my delays on this, because I wanted to finish the editing and get the video out before I continued the project. Had I started this project and worked on it straight through, I could have had this thing probably up and running in 2 weeks. So based on that 2-week time frame and the amount of materials, actual cost here, this is incredible compared to something like a Husqvarna or Roomba's new mower. The Husqvarna is like $1,500. I've probably got $50, maybe $100 worth of material here, and I can still tweak it. I can make it do things that I want to do. If I want to put a GPS in here and try to do GPS location based so that it doesn't leave within a geofence, I can do that. All of these things are still open because it is still open source hardware. So I will continue to do this. I'm going to finish this one up and I'm going to start the next one. Once I have a couple of these things done, I'm actually going to put them all out in the yard and see how they all work and see if I can make all of them work together using the same boundary wires and that type of thing, and then see which one actually works better. One of the designs that I've looked at actually just released an update called the Max Volume, and it has 3 cutter discs, and it has a cutting area on the front that's about this wide, and then it just has a little drivetrain on the back that just pushes the thing through. It literally looks like those tractors you see on the side of the road that have the cutters out on the sides. So there's a lot of options that we can do with this, and I'm really excited that I've actually gotten this one to the point where it has been cutting the grass. I do have some changes I'm going to make to it. I do want to play with seeing if I can get it to return to a central base to recharge on its own. And because the Arduino still has some pins open, I'm even looking to add this to my Sensors network and see if I can get my home automation system to trigger this thing to go out and to mow the yard. So we'll see how that works. But I hope this feedback will answer some of the questions that you guys have had. And if you have more questions, let me know. I'll be happy to answer them.